Yeah, thanks Lee for that. My topic was interchanging data with PDMS. Back in late August last year, I took a support call from a customer who wished to transfer data in and out of a package made by Viva called PDMS. PDMS stands for Plant Design Management System. And I invited the customer, as Lee said, to speak today, but late in the piece they declined due to confidentiality clauses they and the company were forced to sign with the government. But anyway, I'll do my best to explain what we did. Basically, as 12D model creates a database for a civil design, PDMS creates a database for a process design. PDMS is an engineer-controlled design software package for design and construction in offshore and onshore oil and gas industry, chemical and process plants, mining, pharmaceutical, food industry, power generation, paper utilities, and most of all, desalination plants. Here's just a little example. The other packages that are out there that do similar things, there's Navisworks, which some people may be familiar with as well. Here's an example of a visualisation of one of, I think it's a small refinery or something that they gave me. If I just run that. Basically, one company was doing the plant design and the other company was doing the associated infrastructure, like the sewer design, the water main design, the road access design. And when I was contacted, the design checks were all being done as a post-process with paper. The process designers did not really know where the other infrastructure was going, and vice versa for the infrastructure engineers. And this is an example of like how complex some of these designs can be. You can see how much detail is in the process design. PDMS is used to generate the layout drawings, detailed drawings, together with a materials takeoff, and it also can be used to produce things like valve schedules and the like. PDMS can also show the electrical and instrumentation design. It can be above or below ground. As the data in the database, it made sense, as all this data was contained in the database, it made sense for us to firstly try and get some of the information out of PDMS, and it became obvious to us from an early stage that the hydraulic pipes in this particular project were the most important. There were some concrete slabs that the process equipment sat on. These were entered manually in this project because they didn't really change that much. We found that PDMS was available. Basically, in this job, I had they wanted a quick turnaround of about a week for me to get something to them that they could read these hydraulic pipes into 12D so they could design around them. I found that PDMS, spoke to them, and that PDMS was able to give us a CSV report of each particular pipe. So there we had basically the end of each pipe, the two ends of each pipe, the length of the pipe and the size of the pipe, and also the zone of where it was going on the plant and what its actual function was. I basically created it in Excel because it was a very we didn't know what we were really shooting at the start, and a lot of people were looking at the information that was coming out of this data, and I just found it was easier in Excel to make very quick changes to try and include more data or get rid of data that they didn't need. So I created this. I created an Excel file that could read the CSV file that was produced from PDMS, and then created a Visual Basic macro that turned that CSV file into a 12DA macro, and that was all done within Excel. I also had some lookup tables for things. They were sending, part of it was to, the zone was coded, and I was able to make use of the lookup table to name certain strings in 12D so that they could be mapped when they were, the 12DA file was eventually read into 12D. And basically, that all said, it just ran from one click of a button to create the 12DA file. It just generated a normal 12DA file. And what we read into 12D, here's an example of some of the pipes we read in. And you can see that they've come in different colours because we were actually able to apply the mapping file when the data was brought in. From there, the infrastructure designers had the hydraulic pipelines in 12D, so they were able to design their drainage network around it. But there was another process we needed to do. We needed to get the drainage and the sewer back into PDMS, and this is all within a week. So basically we made use of a drainage plan plot to create the inverts of all the sewers and the drainage that was designed. Then I wrote another quick macro for them that basically used that information and then created a CSV file that could be read again into Excel. And from Excel we created a script file that could be read into BRICSCAD. And then the result of that was to create a 3D DWG that could be then read back into into PDMS. So the script file was created. It was just like a long series of commands that was just dragged and dropped into BRICSCAD, as you see, and it built up the drainage design. And then I was just able to save it as a 3D DWG that PDMS could read. So you see it's there creating it from the script file. It would be handy if we could take out the drainage superstrings as cylinders. We can't yet do that. So there you go, there's the drainage network being built up from those script files. So then we got that's an example of the wireframe in BRICSCAD showing the pipes or the cylinders that were created. This was then passed to PDMS for their clash detection. They ran a clash detection part of their program over it, so they had areas where it was like glowing red where it didn't meet the clearance requirements for the service clashes. I guess the next step is to go and write it all in 12D macros, because in their project they had around 800, I think it was, hydraulic pipes, and through Excel it probably created the 12DA file in around probably a minute and a half. And you can really speed that up with a lot of with a 12D macro. It's just the information that was produced from PDMS. The CSV file was quite messy, and there were a lot of it was hard to sort of pick the data out of that. So I'm working with Aviva there to try and come up with a format. Hopefully they can write directly to 12DA. That would be probably the best solution for us. Pipes with wall thickness would have been good. In the end, as I took the data out of 12D for our drainage pipes and things, I didn't actually use the diameter of the pipe. I had a line style set for each particular drainage pipe, and that line style name was actually the outer diameter of each pipe. So that worked well for us when we came to check clearances. We didn't do anything with the maintenance holes or the pits at this stage, but I can see further opportunities to work on that area of the project. In the end, the project was a great example of how 12D model was flexible enough to exchange the data really quickly and efficiently to another package, and it actually saved the customer countless dollars in rework, and more importantly in this job it was the time pressures that designers were under, so they were very pleased with the outcome. And that's it.